Hi, in this project, I took the Disney dataset. This is very popular dataset. I've given some information about this dataset. Here, I wrote some description about this dataset. Here, Walt Disney Studio is the foundation on which the Walt Disney Company was built. The studio has produced more than 600 films since the debut film was that Snow White and the Seven Dwarfs in 1937. While many of its films were big hits, some of are not. In this notebook, we will explore a dataset of Disney movie and analyze what contributes to the success of this Disney movies. Okay, if you are, and also first we will take a look at the Disney data compiled by this person, Cali Grad. You can check this data set in this data.world. They given good information here about the uh, data set. Please, this is the data set. There is nearly 579 rows are there. Almost 1, 2, 3, 4, 5, 6, 7 columns are there. So if you see this first column, first column is the string, second column is the date. There is icon is there, right? This icon, date icon. There is a string icon and string and map. One MPAA rating is another string, and this is the decimal, which is total grass, and inflation adjusted grass decimal. So we are working on this data set. So basically, there is a generic also there. Sorry, genuine is there. Jury is there. Jury, in this jury we have this also string. So there is 7 columns and 537 rows are there. So we are working on this data set, and the data set contains 579 Disney movies with 6 features: more movie title, release date, jury, MPAA rating, total grass, and inflation adjusted grass. So there is 6 features are there. But here, as I said, but one movie title is 1, 2, 3, 4, 5, 6. This is something 1, 2, 3, 4, 5, 6. Yeah, 6 features are there. So we will explore this data set. First, I will import the pandas library. Import pandas pandas as pd, and read the pandas, like I will read pandas here. While reading, release date is the date column, right? I need to parse the date. So gross equal to pd dot read, let's read underscore csv. So already I have downloaded and I kept here. Give me a second. Here, this is the data set. No, not the project. No. Not the project. This is the data set. Disney. Yeah, I copied already. Had copied that. So directly, I'm going here and I'm writing. I'm giving the path. Open data sets slash. What's the name of the file? File name is Disney movies total grass. Okay. Dot csv. From that, I'm parsing the release date. So par underscore date, DEATES dates equal to, I need to provide as a list here. What is the list? Release date. I will copy directly. I will copy the release date from here. Release date. Yes. release date. I'm printing the grass here. GRO versus grass dot HE head. If you see this one, it's taking time. Yeah. Now records are there is a. If you see this one, there are five records are loaded here, and movie title, release notes, jury, MP rating, total grass, inflation, adjusted grass. So this field is important for us, and jury is important. So when come to the inflation adjusted grass, this is total in grass. So we will work on this too. So first, again, I will do one thing. I will enter the top 10 values so that with the ascending order, so that you will understand. So inflation, same word. I don't want to inflation economies. I'm printing the descending order. DESC is equal to DESC is equal to RO SS grass dot sort 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 values VALUES values. Need to pass the which value which column need to descending under the same column inflation comma ascending order SCENDI descending is equal to FALS false, ascending false, and also inflation. I'm printing the top 10 values dot head of 10. See, this I print the top 10 values. If you see this one, this inflation, this much value, I don't know how to this much, and next one, this one, and if you see this one, jury is music, adventure, music, comedy. These are the top 10 values. So let's start the exporting data. We will check the which top Disney movie that have the earned the most at the box office. These are the most box office collections. We can do this by sorting movies by the inflation adjusted graphs. We will call it as adjusted graphs from this point onwards. Okay, you understood, right? These are the top popular box office movies, collection movies. Okay, then we will see the movie jury trend. Okay, from here, first thing, in this section, this is third section, that is movie jury trend. I will read this sentence from the top 10 movies above. The top 10 movies above, we already printed here. The values are already there. It seems that some juries are more popular than others, so we will check which juries are growing stronger in popularity. To do this, we will group movies by jury and then by year to see the adjusted gross of each jury in each year. Very simple. First, we will from the release date, we will sort out the year in this here in this code section, and then we will compute the mean of adjusted gross per jury and per year, both the things in this section I'm talking about. And next data, we will convert the particular group into reset the index for that group. Okay, here what we got the values, we have reset that to group, and also we will print the head of that data frame. Okay, so first I will take the release nodes from the grass, release here from the grass. So what I need to CROSS grass RELEASE release y here equal to what we have. We have what is that? pd dot date date time index gross CROSS gross RELEASE release date. Okay, dot y here. Okay, just I compile. Release nodes is the release date. What I wrote here. Okay, spell mistake. Release. Then we next compute the mean of existed gross per jury and per year. We will group by with these two. Okay, we are create one data point GRUP group GROSS cross dot GROUP group by group 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 by what two things I need. One is jury JENRE jury comma release year. What is that? Release year. I already sorry. What is that? RELEA is release year. Release here. Same thing I will copy here. From that I will calculate the mean. Okay, from that I will convert the group by object to data frame. Okay, how to do this group by object? This one I'm talking about. I will come to the data frame. How group by this is yearly, right? Group by group. Okay, now this I will create another object. Jury underscore YEARLY equal to GROUP group dot reset underscore index. Okay, we convert it to the reset the index. Then I will print the yearly dot header 10. Okay, something is not right here also here is there, right? First jury 1981 cross illustration again by EPS. Something I made a mistake. Gross release year is correct. Group by release date, not here. Group graph by jury comma release year dot mean, correct, and the reset index. Is there a mistake here? Okay. Okay, understood. Earlier we name it as release here, right? Here again it happened. So what I will do, I will run from beginning so that it will refresh. Yeah, now it's done, right? Okay. Then here we have action. Here this is mean of that, and this also mean, and for the actions. Okay. This action. Jury is action. Okay. Here in this section, in this section visualization the jury popularity trend. We will make a plot out of these means of groups to better see how box office revenues have changed over time. Okay, we will do the plot now. Import, SEA BORN born as SNS. This import CBORN. No, here SEA BORN. No, no. Yeah, I will do the one thing. Just saying that there is no margin CBORN. So I need to install this one. PRTK NSTGL install CBORN. Yeah, I have installed the CBORN library. So I will plot this SNS dot rel plot and plot find equal to line as a line, comma x is equal to what I need xx release here I need release here and here, and also y is my inflation adjusted gross. These values I'm giving here, and also I need to provide the here that should be also June comma date date is equal to jury yearly. Okay, something's wrong here. What is it? Please here. So this is x, right? What's wrong here? Yeah, release here x, y, and yeah. If you see this one, 2010, there is the action and also adventure. Yeah, the trend is two things. One is action and adventure. If you see this line chart, so we need to explore these two: action, adventure. Okay. In this section, data transformation section, I will discuss about the dummy variables. Okay. In this section, I'm going to talk about the data transformation. Yeah. Here I wrote some notes, small notes. Please read it. I will read these notes. The line plot suppose our belief that some juries are growing faster in popularity than others. For Disney movie, action and adventure juries are growing the fastest. Yeah, there is two lines. One is orange, one is pink color is there, right? These two that we are talking about. Okay. Next, we will build a linear regression model to understand the relationship between jury and box office gross. So, since the linear regression requires a numerical variable and the jury variable is a categorical variable. Okay, jury is the categorical variable, right? Action, adventure, right? So, we will use a technique called one-hot encoding to convert the categorical variable to numerical variable. Okay, the technique transforms each category variable into a new column and assign a 1 or 0 to the column. Okay, that is called dummy variable concept here. One hot encoding. For this data set, there will be 11 dummy variables. So how many? Action, adventure, total of 11. dummy variables. One for each jury except the action jury, which we will use a baseline. For example, if a movie is an adventure movie like The Lion King, the adventure variable will be 1 and other dummy variables will be 0. Since the action jury is our baseline, if a movie is an action movie such as the Avengers, all dummy variables will be 0. Okay, this is the concept about a dummy variable, and we are doing that. Yeah, I'm writing this code here. One is convert the variable to dummy. So how to do that? So there is the in a pandas there is a get dummies one method is there. I will use that jury jury underscore dummits is equal to pd dot get dummits dummies. In this I need to pass gross zero gross of what that is jury jury. This I need to convert it as a jury. So I'm dropping the first. What is the first? That is action. Action. I'm dropping that. As I said, that is the baseline for our investigation. F5 RS is equal to TRQ2. And inspecting what is jury. Just doing head head. So we converted it as a dummy variables. So we understood, right, how to convert dummy variables. Next section I'm going to talk about the jury effect. Okay. In this section, this is the sixth section, the jury effect. Now that we have a dummy variables, we can build a linear regression model to predict the adjacent gross using these dummy variables. Okay, from the jury model, we can check the effect of each jury by looking at the coefficient given in units of box office gross dollars. We will focus on impact of action and adventure juries here. Note that the intercept and the first coefficient values represent the effect of action and adventure juries respectively. We accept that movies like The Lion King or Star Wars would perform better for box office. Okay, this is notes I wrote already. Please understand, we are doing the linear regression model now. Okay, to predict the adjacent gross. Okay, now I'm importing the library from sklear dot linear model model import linear regression. I will check that whether this library installed or not. No, this library is not yet installed. So pause and install this. Here, sklear dot linear model import linear regression. Yeah, correct. Yes. Now reg regression equal linear regression, and from that I need to fit that model reg dot fit and that I need to pass to my continuous variables. What is that? Here is the x and response variable. What is the response variable? Gross. We need to predict gross inflation. This way. Okay. Then get estimated intercept here. I need to get the intercept set. Action is equal to this is dot here enter intercept. Yeah, I got the intercept and also adventure dot co coefficients in it 0 and that I will print that here, right? And to print what I need action from adventure. So this is the coefficient. This is one intercept and this is one intercept and this is standard error and this is the standard error. Beta naught and beta 1. This is the beta 1. This is the beta naught. Okay. This is general the regression equation. This is the beta naught plus beta 1. This is the beta 1. Okay. Regression coefficients and intercepts. Okay. Then I will move to the next section, that is the confidence intervals for the regression parameters. Now, yeah, in this section, I'm going to talk about confidence intervals for regression. Yeah, first section. Yeah, I'm reading this my notes. Confidence intervals for regression parameters. Next, we will compute 95% confidence intervals for the intercept and coefficients. The 95% confidence intervals for the intercept A and coefficient Bi means that the intervals have a probability of 95% to contain the true value A and coefficient Bi respectively. If there is a significant relationship between a given jury and the adjusted grass, the confidence intervals of its coefficient should exclude 0. We will calculate the confidence intervals using the Pairs bootstrap method. Okay, we will do that. So first, to do that, I need to import the library. About that library, I will first NumPy I need to import. import import NumPy as NP. Here IMDS means is equal to np dot array and range of 0 comma length of what I need to cross grass of jury JGN RE jury I need to pass it. So I will take the size of 500. The size is equal to 500 and BS underscore action underscore reps equal to np dot empty. What I need to pass size. Same thing for actions. Add BEN adventure. Yes. What mistaken? Class GROS correct. Now mistakes here. Yeah, we did the we calculated the bootstrap. This is bootstrap method, Pairs bootstrap method. Okay, then confidence intervals for the regression parameters. Yeah, in this section, eighth section, again the confidence intervals for the regression parameters. After initialization, we will perform pair bootstrap estimate for the regression parameters. Note that we will draw a simple sample from a set of jury adjusted gross data where the jury is the original jury variable. We will perform one hard encoding after that. Okay, we will do that. Generate the replicates. Okay, here for I need to create a for I in range and delay of size. Okay, then resample the indices for bs underscore ind s is equal to np dot then d1 random dot ch4 and choice of inds comma length of what is that inds. Okay, then here get the sample jury and sample adjusted gross. How to get that? We bs underscore gen at jury equal to gro sys cross of gen jury of what is that jury of this one. Okay, next this is jury, right? We need to cross. We need a gross. Gross, what I pass here, inflation. Okay, then get the dummy variables. bs. Convert the sample jury to dummy variables. bs underscore d2 dummies equal to dd dot get underscore du dummies. One need to pass two rows. One is bs underscore jury. From that I mean drop the first one. What is that? First one action underscore fi or test first one. We drop that first value, then we are fitting the regression. What is it? Linear regression. On the REG dot fit. So fit what I need to pass here. First continuous variables get es dummies I need to pass dummies comma gas. Then get the compute the duplicates of estimated intercept and coefficients. How to compute? So bs already we have this one, right? bs I variable curly I equal to regr dot in enter set c pt set underscore. Okay, then what I need another value that is intercept and coefficients of equal to regr dot coef underscore there is a mistake here, size. Mistake. So, and this is not defined. Somewhere I made mistake. 1 second. Sorry, there's a mistake here. I need to same made a mistake here. Let's compare. Okay, so in this section we worked on these two things. We got the coefficient, intercepts and coefficients. Next section, ninth section. Yeah, in this section, ninth section, confidence intervals for a regression parameters. Third, finally, we compute 95% confidence intervals for the intercept and coefficient and examine if they conclude 0. If one of them or both does, then it is unlikely that the value is 0, and we can conclude that there is a significant relationship between the jury and the adjusted graph. Sorry. So we will do that. So how to do that? I will need to write a code here. First, confidence, confi D A D E A and C. Just name it is I get enter val underscore action is equal to np dot pgr per percentile on that I need to pass bs action, all these things, comma, and 2.5, comma, 97.5. Okay, same thing I will do this. And we will choose an adventure percentile BS adventure at choose an adventure 2.5 and percentile. So we will print both. Here I print action. Here I print so this is, if you check this one, there is a 7.4, 1.3, 3.3 and 1.4. Yeah, in this section I'm concluding here. Should Disney movie more action and adventure movies? So I can say yes. So what I wrote here, the confidence intervals for the bootstrap method for the intercept and coefficient do not contain the zero value. So in this both the confidence interval there is no zero value. As we have already seen that lower and upper bounds of both confidence intervals are positive. There is no negative value here. And also there are from the results of the bootstrap analysis and the trend plot we have done earlier, we could say that Disney movies with the plots that fit into the action and adventure jury, according to our data, tend to do better in terms of adjusted graphs than other juries. So we could expect more Marvel, Star Wars and live action movies in the coming years. So what I meant to say that we just finally I'm writing like this: more action and adventure movies equal to more. That's it. So we are expecting more action and adventure movies in coming days, so that the adjusted graphs will be increased significantly. Okay, that's it about this project. Please post your comments in the below so that I can give you my answers. Thank you very much. Bye.